This is a May-June 2022 variant 42 question. 3A carries 2 marks. We have to define specific latent heat of vaporization. In order to answer this question, you need to know the meaning of specific latent heat of vaporization. And you need to focus on two things. The word specific means per unit mass. And then when the liquid is boiling at its boiling point, the temperature remains constant, even though heat energy is still supplied to the substance. So the definition for specific latent heat of vaporization is the thermal energy or heat energy per unit mass to change state between liquid and gas at constant temperature. Then for part B, the specific latent heat of vaporization of water at atmospheric pressure of 1 × 10⁵ Pascal is 2.3 × 10⁶ joule per kilogram. A mass of 0.37 kilogram of liquid water at 100 degrees Celsius, which is the boiling point of water, is provided with the thermal energy needed to vaporize all the water at atmospheric pressure. Part 1, we have to calculate the thermal energy Q supplied to the water. To do this question, which carry 1 mark, we need to use the formula Q equals ml, which is the formula to find the heat energy given to a substance at its boiling point. So the mass is given 0.37, the specific capacity is 2.3 × 10⁶. This will give you 8.5 × 10⁵ joule. Then for part 2, the mass of 1 mole of water is 18 grams. Assume that water vapor can be considered to behave as an ideal gas. Show that the volume of water produced is 0.64 meter cubed. This question carries 3 marks. To score the 3 marks, we must first use PV and RT, which carries 1 mark. Then from there, we rearrange the formula to get V equals to nRT over P. And you notice we need to know N, T, and P. P is given to you as 1 × 10⁵ Pascal. Temperature, it must be changed to Kelvin, which means you must know how to change temperature from degrees Celsius to temperature in Kelvin. So it'll be 100 plus 273, which will be 373 Kelvin. That is the temperature. And then we need to know the number of moles of water, which is the mass of the water, 370 grams, divided by the mass of 1 mole of water. When you substitute the values into the equation, you get 0.64 meter cubed. Then for part 3, assume that the initial volume of the liquid water is negligible compared with the volume of the water vapor produced. Determine the magnitude of the work done by the water in expanding against the atmosphere as it vaporizes. To do this question, you need to know that the work done by a gas, in this case water vapor, is P times delta V. P is the pressure, delta V is the change in volume. The pressure is given to you as 1 × 10⁵ Pascal. Then the change in volume is 0.64 minus 0. 0 because the question says that the initial volume of the liquid water is negligible. So this will give you 6.4 × 10⁴ joule. Part 4, use your answer in B part 1 and B part 3 to determine the increase in internal energy of the water as it vaporizes at 100 degrees Celsius. Explain your reasoning. To do this question, we need to know the first law of thermodynamics, which is delta U equals to Q plus W. Your Q is the heat energy supplied to the water, which is calculated from B part 1. The answer is 8.5 × 10⁵. And then your W is the work done by the water as it expands. So this will give you 7.9 × 10⁵ joule. The reasoning is given here. The water vapor produced by the water pushes against the external atmospheric pressure. Therefore, work is done by the water. W has a negative value, which is why I put the negative value here. And then for part C, use the first law of thermodynamics to suggest with the reason how the specific latent heat of vaporization of water at a pressure greater than atmospheric pressure compares with the value at atmospheric pressure. This question carries 2 marks. In order to get the 2 marks, first you must know that the work done by the water vapor as it expands is equal to P times delta V. Since the pressure is larger, since the atmospheric pressure is larger, work done by the gas has a larger negative value. This will carry 1 mark. Then you must use the first law of thermodynamics. Your W is negative because work is done by the gas. So your delta U equals to Q minus W. Delta U equals to Q minus W. So your delta U plus your W equals to Q. Q is the heat energy supplied to the boiling water. So therefore, more heat energy must be given to the boiling water. So your Q becomes larger. Therefore, your L will increase. And then this is a summary of the facts that you must know to solve this question. You must be able to define latent heat of vaporization. Number 2, you must use Q equals to ml to solve problems. Then you must be able to convert the mass of a substance to number of moles. Then be able to convert temperature from degrees Celsius to Kelvin. Then number 5, recall and use work done equals to P times change in volume. And then for number 6, understand that work is done when a substance expands against an external pressure. W has a negative value. And then number 7, recall and use the first law of thermodynamics. Delta U equals to Q plus W. And of course, you must understand the meaning of the word specific and latent.